The teacher talking is the teacher Stephen of the St. Kevin Nyali Elite High School, and a passionate teacher of mathematics and chemistry, and also a next examiner paper 3 chemistry. So let us walk together through this journey of a very simple subject in the world, that is the topic that you have to understand very well, because it is a topic that can be examined both in a practical and also in paper 1 or paper 2 as a flowchart. So you should be able to understand this very, very well. So we have the objectives that you have to know at the end of this lesson, and I want you to be very careful and follow whatever we are going to do in this um, lesson. By the end of the lesson, the learner, which is you should be able to state all the reagents and apparatus used in the preparation of chlorine gas. You should be able to know that. Um, Also, by the end of the lesson, you as a learner should be able to draw the setup. You should be able to draw the setup for the preparation of the chlorine gas. If you do so, I think you will count yourself as the luckiest person in the world. That is very magnetic. And also by the end of this lesson, you should be able to explain the laboratory preparation of the chlorine gas, which is very, very vital. If you will be able to explain this, trust me, there is nothing that you will be able to miss in exam testing in the preparation of the chlorine gas. Thank you. Let us now see the next slide. The next slide. Now, this is now the preparation. Now we are preparing the chlorine gas. And I want to tell you this, the chlorine gas should not be prepared in, the chlorine gas should be prepared in the fume chamber or in an open area, open air. It should not be just prepared in the normal laboratory where you always prepare oxygen gas, hydrogen gas. No, this one should be prepared in the fume chamber or in an open air or area, because chlorine is very, very, very poisonous gas, for your information. So this gas, because being that, why do we say that it is very poisonous? It has a pungent smell and choking, irritating smell that might interfere with your respiratory organ or system. Are we together?
Yes.
Thank
Yes.
you. Yeah, thank you very much. Thank you. So we have said this gas should not be just prepared in the laboratory normally. It should be prepared in a fume chamber or in an open air, because this gas has a pungent smell, irritating, pungent smell, choking smell that can interfere with your respiratory system or organ, whichever the case. So for this, for you to be able to prepare the laboratory gas, to be prepare chlorine gas, there are things that you have to know, the reagents. We have at least 4 ways on how we can prepare this gas. The first one, we can heat the solid manganese 4 oxide, by concentrated hydrochloric acid. Manganese 4 oxide is an oxidizing agent. So it is being used here because it will oxidize. It will oxidize hydrochloric acid to water and chlorine gas. You have to know that very well, and it itself will be reduced. We'll explain that magnetically, and please work with me as I explain this into details. Another one is heating the lead 4 oxide plus the concentrated hydrochloric acid. Lead oxide, I think you talked about, you have learned about this thing called we call them amphoteric oxide. Lead oxide is an example of amphoteric oxide. So I'll be able to explain that as we proceed. Also, check, if you check this very keen, the solid manganese oxide and concentrated hydrochloric acid can only react well when there is presence of heat. So that one you have to know, because the setup might be drawn for you. Sorry, the setup might be drawn for you, and you are asked to maybe identify a mistake. So if you don't see the source of heat when they are using solid manganese oxide and concentrated hydrochloric acid, you will just know that, sorry, I can see somebody writing the message here. Let me see. Some people are just chatting, which is very bad. You can, don't mute yourself. You know, when you are sending message to everyone, you know that your message is being read by everyone. Thank you for that. So you must be very keen on whatever we are doing. Don't interrupt the lesson. So what I was saying is that when we are preparing this gas chlorine by using solid manganese oxide and concentrated sulfuric acid, there must be presence of heat. What are they sending the message? Too many messages here. I died. So who are these? Just remove them because uh, they are really interfering. That is Quinta Nyangol. Let me remove the person because I don't always entertain nonsense in the class. Instead, they are chatting, and with us, we are very busy learning, which is very, very bad. Just relax. I want just remove some people here. They are not serious. Let's continue.
Forgive them.
You know, I don't want the people who are disrupting my lesson. That is what I really hate. I've taken my time to do this, and I don't want to waste a lot of time. Instead, I should be even with my family now. Let's proceed. There is also another way of preparing the chlorine gas, that is reacting potassium manganese 7 with a concentrated hydrochloric acid. If you check this thing, they are just oxidizing agents. Uh, that is what you have to know. Also, we have this one that is reacting potassium dichromate 6 or sodium dichromate 6 with the concentrated hydrochloric acid. That is also a way of preparing the gas. Another thing that all this you have to know them. Know all this. Tafadhali, know all these reagents. That is one of the objectives that you should know. One, we can prepare chlorine gas by heating solid manganese 4 oxide and concentrated hydrochloric acid, to mean you place them in a round bottomed flask, then you heat by setting the apparatus on how you will be able to see it in the next slide. Also, another one is heating lead 4 oxide with concentrated sulfuric acid. You should be able to know that. Then reacting potassium manganese 7 with concentrated hydrochloric acid. Then also another one reacting potassium dichromate 6 with the concentrated acid, or reacting sodium dichromate 6 acid with this, what we call the concentrated hydrochloric acid. Now let us now check this. You can be able now to the setup of laboratory preparation of setup of school laboratory preparation of chlorine from a concentrated hydrochloric acid and oxidizing agent. There are some oxidizing agents that we have talked about. Who can give me one of the oxidizing agents that we have talked about? Yes, fire. Hey, why are you calling yourself fire? Yes?
Nothing. Sodium manganese. Manganese oxide.
Sodium?
Manganese oxide.
Sodium?
Not sodium, solid manganese oxide, sorry.
Yes, so that is the solid manganese oxide. So you can just say manganese oxide is an oxidizing agent. I am. Who will also give us an oxidizing agent here? Elijah, Macharia.
Is this true to say that KMNO4 potassium manganese 7?
Potassium manganese 7, that is also an oxidizing agent. Another one?
Sir?
Yes?
Cranium, dichromate 6 ions.
So you can say the
Orange.
or instead of you can say that is potassium manganese 6. That is what we call the dichromate. That is potassium dichromate 6. That is also an oxidizing agent. The potassium dichromate 6. Yes, that is also. So this one, those who had done this topic in Form 3, that is we call it organic chemistry. You talked about this one, this oxidizing agent. It helps us to differentiate between the unsaturated hydrocarbons and saturated hydrocarbons. Are we together?
Yes.
Yes, thank you. Let us now discuss this now into details. Now, if you check the apparatus, let me pick the pen now in this process, I pick the pen. So if you check in this place, we are using this, what is called the manganese oxide. And you can see there is source of heat here. Heat is here. And also we have the concentrated, it must be a concentrated acid, that is hydrochloric acid. Then we have water in this place. Then also we have the concentrated sulfuric acid. Also we have the cupboard. We have the dry chlorine gas. So I want to explain this diagram very keen. Where you think you can write something, just write, because now we want to discuss all the possible questions that can be asked from this. One, you can be drawn this setup, then they write here liquid X. If they ask you here liquid X and you write hydrochloric acid, you will be marked wrong. You have to indicate the word concentrated hydrochloric acid. So just writing hydrochloric acid without the word concentrated, you will be marked wrong. So you have to be very keen on that. So this is how this thing works now. This one, I said the manganese oxide and the concentrated hydrochloric acid can only react in the presence of heat. When the heat is not there, the reaction cannot be effective. So that is what you have to take in place. So manganese oxide react with concentrated hydrochloric acid in the presence of heat. This manganese oxide will oxidize the HCl, which is now the acid, the concentrated acid. It will oxidize it to what? It will oxidize it to water. It will oxidize this to water and chlorine and the chlorine gas. The chlorine gas is a diatomic gas. And maybe we didn't say that chlorine is atomic number 17 in the periodic table. And now this chlorine gains 1 electron to become stable, forming an ion, that is the negatively charged ion. And also it falls under the chemical families known as the halogens in the periodic table. That is group 7, which is known as the halogens. The chemical family of that group is now the halogens. So this chlorine is diatomic. To mean di means 2. It has 2 chlorine atoms. That is what we meant by the term diatomic. Then this now, the manganese oxide will now be reduced. The manganese oxide will be reduced to, who can tell us?
Sir, pardon.
I've said manganese oxide is an oxidizer. So it oxidizes the hydrochloric acid, the concentrated hydrochloric acid, to water and chlorine gas. But itself, it is being reduced. The manganese oxide is being reduced. Manganese oxide is being reduced to what?
Manganese 2 oxide, MnO2. Manganese 2 oxide, MnO.
MnO.
Manganese 2 oxide, yeah.
Manganese 2 oxide. So which kind of reaction is this? What is the name of this reaction?
Redox reaction.
A redox reaction. So a redox reaction, what is a redox reaction? A redox reaction is a reaction where the oxidation and reduction takes place simultaneously. It is a reaction where the oxidation and reduction takes place simultaneously. For example, if we write this word here, the word redox, redox, like this. So if you divide this thing up to here, so from here is red, which stands for reduction. Then this ox is now the oxidation. The oxidation stand for, excuse me, sir, before you continue, why are we not to heat information? Permanganate. I'll explain
Excuse me,
that.
sir.
Yes.
Is it redox or is it Tedox?
Redox. Redox.
Okay. Okay.
Thank you. Somebody is writing Tedox. No, it is not Tedox.
Yes.
It is redox reaction. It is a redox reaction. I'll tell you why we are not using the heat the other side. Don't be worried. Then we have this water. When we heat this, we have now seen what will be formed. We will form the water, manganese 2 oxide, and the chlorine gas. That one. And now all those. Let me see what this was saying. Yeah. Okay, let us proceed. So this one is in this flask will now form the three things, that is water, manganese 2 oxide, and chlorine gas. Now all these things will pass through this process, this delivery tube. And from here, when reaching here, the function of water here is to remove the traces of the hydrogen chloride, the traces of the hydrogen chloride. The function of water here is to remove the traces of the hydrogen chloride fumes, to remove the traces of the hydrogen chloride fumes. So that is the function of water. So the function of water here is to remove the traces of the hydrogen chloride fumes. Then now the gas will be passed now. Sorry? Fire, kindly mute yourself. The gas will be now passed through this conical flask containing the concentrated sulfuric 6 acid. The concentrated sulfuric 6 acid now here will act as the drying agent. To mean it will dry the chlorine gas. It will dry the chlorine gas. So that is why it is passed through this. So it is passed through concentrated sulfuric 6 acid to be for the gas to be dried. Here we cannot use, I know we have other drying agents such as we have calcium oxide, we have anhydrous calcium chloride, very good, and also we have the silica gel. Also we have this another drying agent that you know, apart from the sulfuric 6 acid. Yes. Yes. Are people getting me? Are you able to get whatever I'm saying?
Yes.
Yes. Apart from HCl, the not HCl but sulfuric 6 acid, the concentrated one, which other drying agents do you know that can be used in drying gases?
Calcium oxide.
Huh?
Calcium oxide.
Calcium oxide, very good, correct. Another one?
Calcium chloride.
It is called anhydrous calcium chloride. Are we together? Anhydrous calcium chloride. So when you are using the solid, this is what you have to know. When you are using the solid drying agent, the drying agent must be put in a U-tube. When you are using the solid one, like anhydrous calcium chloride, you can use it when and you place them in a YouTube. But like things like liquid, you put in a conical flask, like this sulfuric acid. You should be aware of that. So here we can also use the silicon gel that you will be able to see. Then now the gas. Sorry?
Excuse me, can you write the name, the silicon gel, for us?
Okay. In the next slide also, you will be able to see it. Silica. Like, yeah, gel. Like that.
Thank you.
Yes, in the next slide, you'll be able to see that as well. So from there, let us now see, we have known the function of this water, where I've said it is used in to remove the traces of the hydrogen chloride fumes. We have talked about the function of the concentrated sulfuric acid, which is used as a drying agent in this place. We are now talking about this one, the collection of the gas. The gas is collected by downward delivery or upward displacement of air, because the chlorine gas is denser than air. Chlorine gas is denser than air. Let us see. How can we know that chlorine gas is dense, is more dense than air? Chlorine gas is written as Cl2. And also oxygen gas is written like this. So air, we refer it as oxygen gas. From here, let us know their molecular masses. The molecular mass of the chlorine gas. First of all, the atomic mass of chlorine. The atomic mass of chlorine is 35 point. Who can tell us? 35.5. And here now there are 2 atoms of chlorine. You multiply by 2. What will you get? Changamkeni.
71.
Thank you. That is 71. Oxygen, what is the atomic mass of oxygen atom? Is 16. So, and here we have two oxygen atoms. Multiply by 2. What will you get?
Pardon?
You have not gotten me right.
32.
Yes.
Okay, let me repeat whatever I'm doing here. We want to know whether chlorine gas is more dense than oxygen. Is it true that chlorine gas is more dense than oxygen? Now we are trying to calculate the molecular mass of these gases. Molecular mass of chlorine gas, we know that the atomic mass of chlorine, is 35.5. And chlorine gas has 2 atoms of chlorine. You multiply 35.5 by 2, you will get 71. That is now the 71 is now the molecular mass of chlorine. Come to oxygen. The atomic mass of oxygen atom is 16, and oxygen gas has 2 atoms. So 2 multiplied by 16, you will get 32. Are we together? Are we together?
Yes.
Yeah, you respond, because if you don't respond, I will think that I'm in class myself. So if you check, 72 is greater than 32.
32.
Yeah, 71 is greater than 32. To me now, chlorine is more dense than what? Than air. Are we together? Are we together? Are these people with me? Are you able to get to me?
Yes.
Yes.
You respond, because if you are not
Yes.
responding, I'll not
Yes.
know. I check this one. So the chlorine gas is collected by this method because it is denser than air, or more dense than air.
Yeah.
Yes. So this is the chlorine. The chlorine gas cannot be collected by overwater method or downward displacement of water, because chlorine is highly soluble in water to form the chlorine water, which is a mixture of two acid, hypochlorous acid, which is known as chloric 1 acid, and hydrochloric acid. So we cannot collect this gas over water by overwater method. You should know that one. Any question from there before I go to the next slide? The question from this diagram. The question from this diagram. If no question, let us proceed.
Pardon.
Any question from this diagram? Yes, Prudence.
I do not understand how you got 35.5.
Don't laugh. How is that laughing? It is very bad to laugh. It is very bad to laugh.
I'm sorry.
Yes. So, Prudent, are you in Form 3?
No.
You are in Form?
4.
Form 4. Then I think you should be knowing this. So I want you to go back to the periodic table. All these are given in the periodic table. So it is something which is always there. If you go to Form 2, you'll be able to know all this. Sodium is having 23, things like that. I want you to go back and read them. Though in exam, you'll be given. In exam, you'll be given those atomic masses of the elements. But if you're in Form 4, you have been using these things, because in calculating moles, you use it. You used it in calculating in gas law in Form 3, also you used it. So just make it to be part of you. You'll be able to know. And you know where 16 is coming from? The 16 of oxygen.
Yes, I know. It's just because I have come in right now, so I just found that 5.5.
Pole. We were talking about the atomic masses. Are we together? So the atomic mass of chlorine atom, one chlorine atom has 35.5. Sini sawa?
Yes.
We have only 1 minute remaining. What we do, let me end it, then we discuss some questions on this, then we can call it a day. Or we do it next time. You choose.
After ending, do we rejoin?
Yes.
Let's do